Hello students, let's begin with the next topic, that is GSM system architecture. In the previous lecture we have started with the mobile communication basics, that is cellular concept. Today we are starting the topic GSM system architecture. You are having the complete architecture on your screen. So basically GSM architecture is divided into three parts, that is BSS, NSS and PN. BSS is nothing but base station subsystem. NSS is the network switching subsystem, and PN is public networks. So basically we can compare this system architecture, GSM system architecture, along with a computer concept, that is we can consider BSS as a front end, the public networks can be taken as the back end, and the NSS can be taken as a middle logic. So by this way you can easily understand the GSM system architecture. Now we will move block by block. First of all, MS. MS is nothing but mobile station, which is comprising of your mobile phone along with the subscriber identity module, that is SIM card. After that we are having the block called as a BTS, which is nothing but base transceiver station, that is base transmitter receiver stations. The number of BTS are connected to the BSC blocks. BSCs are nothing but base station controllers. After that we are having the block, that is MSC. So the number of BSC blocks can be connected to a single MSC. MSC, which is again connected to the number of registers called as HLR, VLR, AUC and OMC, that is Operation Support Subsystem, which is further connected to the public networks such as PSTN, ISDN and data networks. So we will move block by block to have the understanding. First of all is MS, which is nothing but your mobile phone. The BSS is comprising of the two blocks, that is BTS and BSCs. So you can see that a BSC is can be connected to the number of BTS, and a BTS can be connected with a number of MS units, that is mobile phones or a mobile stations. So the function of BTS is to transmit and receive the signal to mobile station, while the function of BSC is to control over number of BTS which are connected to one BSC. After that we are having the block called as a MSC. We will go into detail of each and every block step by step. So here we can consider the concept of a child-parent relationship. You can consider the block BTS as a child, while BSC will be acting as a parent. So simply by this we can understand the function of each and every block. Here in BTS, if there is a large traffic of calls, that is number of calls comes at a time, so that will be handled by the BSC. As BSC is acting as a parent, so it will be look after the each and every BTS, that is whatever will be the functions that are done in the BTS, that will be controlled by a BSC unit. Okay. To the next level we are having NSS, which is called as a network switching subsystem. Here we are having the main unit called as a MSC, which is nothing but mobile switching center. Before that we will see first of all the detailed function of BSC block. Okay, in BSS, that is base station subsystem, we are having basically two blocks, BTS and BSC. So as we have seen already, BTS is performing the function of transmission and reception of the signal from mobile station. Then these number of BTS are connected to one BSC, means a BSS can have one BSC but number of BTS units, right? So the BSC which is present in the BSS, that is base station subsystem, will be doing the function of controlling over all the BTS units connected over there. These BTS units will perform the process of signal processing as well as transmitting and receiving the signal to each and every MS unit connected to it, that is mobile stations connected to it. Again, these BSC unit, that is base station controllers, will do a very important function, that is allocating channel for the duration of call. Now here, in a simple language, we can take an example. Suppose you have to call to your friend. So whenever you have to establish a call with your friend, there will be need of some channel to communicate, right? So this channel will be allocated by the BSC unit for the duration of that call. Along with that, it will perform some more functions such as maintenance of call. It will look after the quality of the call, that is monitoring the quality. Again, it will control the power transmitted by BTS and the mobile station, and it will look after the handovers. Now, what is the meaning of handover? We'll see it later. Now, here you can easily understand. One BSC unit is connected to number of BTS units, right? So, for easy understanding, you can consider this BTS as simply the mobile tower in your area. Suppose you are present in a particular location or a zone. So for that particular zone, we are having one mobile tower, right? So from that tower, we are getting a complete coverage on our phone. So the function of that tower is to transmit as well as receive the signal to our mobile phone, as well as that will perform the process of signal processing, as it is having the antennas. So it will perform the function of signal processing, that is it will remove the noise from the signal when the call is processing. Okay, so from this diagram you can easily understand. One more thing you can observe over here, that is ABs, which is nothing but the interface between BSC and BTS block. These interface we will going into study detail into the next slide. Okay, so again we will come here. After this BSC block, we are having the next section, that is middle logic, NSS, network switching subsystem, where we are having the very important block of the GSM architecture called as a MSC, which is nothing but mobile switching center. The main function of this block is to switch the call, that is call switching, which is the very important function in the GSM architecture. To this block we can consider as a grandparent. Okay, so you can consider the hierarchy: BTS as a child, BSC as a parent, and MSC as a grandparent. So the grandparent will look after the parent, so MSC will look after the number of BSCs connected to the MSC, right? So here the call switching process will be done by the MSC. Now MSC does the function of controlling and maintaining all such BSCs which are connected to it. So in NSS we can say that number of BSCs are connected to a one MSC, but a single MSC will be present in a one NSS. So this MSC has to perform very large number of operations, which is not possible by the individual MSC. So it is connected with the number of registers, as you can see in the diagram. It is connected to HLR, VLR, AUC and OMC. The function of each and every block we'll see in detail. Okay. Now HLR is nothing but home location register. As its name indicates, it is related to the home network. Now what is home network? You all know very well. Suppose you are living in the area, you are living in Maharashtra, right? So your phone will be registered in the location, in that particular location. Okay. So whatever information is related to your number, that will be stored by this home location register. Suppose you are going to buy a SIM card, so that shopkeeper will ask you for some documents, right? So these documents are nothing but your identity proofs, your address proofs, your profile info. So all this profile information, your location information, that will be stored in the HLR, that is home location register, and it will store this information permanently. So for each subscriber, this profile information, location information and status information will be stored by the HLR of that particular area. Now one more information is stored by this HLR, that is a subscription information of each and every registered user. Now what is the meaning of subscription information? All of you have seen that you are whether you are a prepaid user or a postpaid user, which plan you have activated on your phone, that is whether it is a 28 days plan or a 30 days plan, whether it may be a data plan or the call plan, etc. So that information, subscription information, will be there in the HLR. Okay. So next register is VLR, that is visitor location register. This VLR is always working in coordination with HLR. Okay. For understanding, we'll see the example. Suppose you are present in the, means you are from the Maharashtra and you have to move to the Karnataka for some reason or for some function. Okay. So if you are moving from one state to another, initially there was a concept of roaming, right? Right now we are not having the roaming, but still when you are moving from one zone to another zone, now your HLR is present in the Maharashtra, means your mobile phone is registered for the Maharashtra region. So your complete information will be stored in the HLR of your particular area where you are having your hometown, right? But when you are moving from one location to another for some purpose, so as soon as you are entering into the vicinity of that area or a geographical area, the VLR there, that is visitor location register, will activate and it will ask the MSC of the Maharashtra for your complete detail. So it will ask the MSC. So the your HLR from the Maharashtra will provide the complete details of you to the VLR, that is this subscriber is from our area and this is its complete detail. So that complete information will be stored in the VLR of the Karnataka state, and that information will be stored temporarily. Okay. So always this VLR has to work in coordination with HLR. Okay. Next block is AUC, which is Authentication Center. Now, whenever this complete information is for a particular subscriber information is stored in the home location register or the VLR, these informations must be authentic or protected. So to protect the complete database, that will be the function of authentication center. So the complete database will be protected over here. Again, for each subscriber the information will be protected by some secret key. So these keys will be stored in the AUC. Again, it can protect from different types of frauds which can be happen. So this will be the function of AUC. After that, the operation support subsystem OMC block is there, which is doing the further operations which are related to MSCs. After that, we are having the public network. So further the call will be handled over to PSTN, ISDN or data networks where you have to do the calls. Now look at this diagram. Here we can have the more understanding about the interfaces. Initially in the first diagram you can have the interfaces. See, this BSC, that is BSS and NSS are connected by the dotted line. So this dotted line is nothing but the interface called as a ABIS. Initially MS and BTS are connected by the interface called as the interface, and the lastly NSS and PN, that is public network, are connected by A interface. You can have the detail in the diagram. So these interfaces we can easily understand by this diagram. See, here MS and BTS are connected by the interface, which is nothing but the air interface. The function of this air interface is to transmit and receive the information. Okay, so whatever information that BTS and MS will transmit and receive, that will be through this is nothing but the air interface. Okay, it will use the TDMA technology, that is time division multiple access technology. The second interface which is present in between the BTS and BSC block, that is the ABIS interface, which is used to transmit the information between BSC and BTS. Suppose BSC wants to transmit some information about the calls or traffic to the BTS, so it will transmit this information through ABIS interface. The third interface which is present in the block BSC and MSC, that is called as the A interface. This A interface will do the function of managing BSS, that is it will manage the calls at the BSC, it will handles the call, and it will manages the mobility, that is handovers will be handled over this interface. So this is all about the GSM architecture. Thank you.